Welcome to True Projects. In this video, we are going to explain the project titled Web Mining to Detect Online Spread of Terrorism. Introduction. The quick detection and prevention of the spread of terrorism online in an environment where technology is becoming more interconnected is crucial for maintaining international security. In this project, web mining is used to analyze and track online platforms for the spread of extremist information and attempts at recruiting new members. This project aims to create proactive strategies that recognize and stop the rapid spread of terrorist ideologies by combining data mining and network analysis. This will promote a safer online environment for people and communities around the world. Objective of the project. The goal is to create a comprehensive system with a multifaceted approach for detecting phishing URLs. The project aims to efficiently identify and categorize potentially malicious URLs through the integration of advanced data processing, visualization techniques, and a diverse set of machine learning algorithms including logistic regression, k-nearest neighbor, support vector classifier, naive-Bayes decision tree, random forest, and gradient boosting. The project also broadens its scope to include a user-friendly web interface built on the Flask framework that allows users to input URLs for instant evaluation. By fusing these components, the project seeks to offer a practical, accurate, and user-friendly response to the growing threat posed by online phishing activities. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of ieee 5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements needed are Anaconda 3 and Visual Studio Community version. So now we'll discuss the flow of work. These are all the steps followed to build this project. The first step is import required packages. This step involves importing required libraries and packages like NumPy and Pandas for data manipulation, sklearn for machine learning, and matplotlib seaborn for data visualization. The second step is exploring the dataset, phishing URL feature data. In this step, we employ exploratory data analysis and feature correlation analysis to better understand the phishing URL feature data. These techniques help reveal data distributions, outliers, and relationships between variables, aiding in subsequent data processing and model building. The third step is data processing using Pandas data frame. In this step, we clean, transform, and prepare the dataset using Pandas, ensuring it is suitable for subsequent machine learning tasks. The next step is visualizing using seaborn and matplotlib. In this step, we employ seaborn and matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is label processing. In this step, we employ a label encoder to convert categorical labels into numerical values, enabling machine learning models to work with them effectively. The next step is train and test split. In this step, we segregate the dataset into training and testing subsets. The training subset is used for model training while the testing subset evaluates the model's performance on new data. The next step is building the model. We have used various machine learning models in this project. The first one is logistic regression. Logistic regression is a simple yet effective method for binary classification. It calculates the probability of a URL being phishing or not based on its features. The next model is k-nearest neighbor. KNN classifies URLs by comparing them to their nearest neighbors in feature space, making it apt for recognizing patterns shared by similar URLs. The next model is support vector classifier. Support vector classifier is powerful for binary classification, drawing clear boundaries between phishing and legitimate URLs, enhancing detection precision. The next algorithm used is naive-Bayes. Naive-Bayes relies on probabilistic principles to classify URLs. Its efficiency in handling text data makes it suitable for URL analysis and probabilistic classification. The next one is decision tree. Decision trees partition data based on feature values, aiding in revealing complex relationships within URL data, crucial for understanding phishing patterns. The next algorithm used is random forest. Random forest combines decision trees to reduce overfitting and enhance accuracy. It improves overall phishing detection accuracy and robustness. The last algorithm used is gradient boosting. Gradient boosting builds an ensemble of weak learners, refining accuracy over iterations. It is valuable for detecting subtle phishing patterns and fine-tuning model performance in URLs. The next step is training and building the model. In this step, we employ the preprocessed dataset to train previously mentioned machine learning models. These models learn data patterns and relationships. Subsequently, we evaluate model performance on a separate test dataset employing metrics like accuracy, precision, recall, and F-score to assess their effectiveness in phishing URL detection. This evaluation step helps ensure the models are accurate and reliable for real-world use. The next step is user sign-up and sign-in. In this step, we integrate user registration and login functionalities into the Flask framework. Users can sign up by providing their information and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. So after signing in, users input a URL for analysis. Later, the input URL undergoes data preparation. Trained models analyze the URL for phishing detection and the results are presented to the user through the front-end interface. So this is the accuracy comparison graph. In this graph, on x-axis I have the accuracy score and on y-axis I have different models built. This is a horizontal bar graph comparing accuracy scores of all the models, and we can see gradient boosting model has outperformed all other models in this project. So we will be using this algorithm for making predictions. To execute this project, first we need to open the code folder which contains the project source code files. So this is the assets folder in which I have these images used in the front end. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as pre-processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are the model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is the dataset file in which I have required dataset. These files are created after pre-processing the dataset. And this is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store the user information. Now copy the path of the code folder from the address bar of the file explorer. I'm copying it and open the Anaconda prompt. So use the cd command followed by space and then paste the copied path and hit the enter button. This command is used to change the current directory to the code folder's path. So compile the app.py file using the command python app.py. So after typing python app.py, hit the enter button. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, the Flask framework will host the application locally at the default address and the port, unless configured differently. So copy this local link provided by the framework and paste it into any web browser. I prefer Chrome. So after pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Here we can see a sign up button. Click on sign up button. So it will redirect us to a sign up page. Fill in all these details. The username is TrueProjects5. Give the name. Give the email ID. Give the mobile number. And give the password. After filling in all these details, click on sign up button. So here we can see a sign up page. Give the previously mentioned credentials, username and password. The username is TrueProjects5 and give the correct password. So after giving the correct credentials, click on sign in button. So it has redirected us to the detecting online spread of terrorism page. Provide any URL here and it will analyze the page to determine if it contains content related to terrorism or not. So I am providing this URL and click on check here link. So it has detected some content related to terrorism and recommending us to block the site. So we can see it here. If we still want to view the site, we can click on still want to click continue button. So it will redirect us to that page. So similarly, we can input any other URL and get the recommendations. So click on home button. I am giving another URL this time and click on check here button. So here we can see not terrorist activity site and website is 99% safe to use. So now click on sign out button to sign out. And the conclusion here is this project is of utmost significance in terms of global security. With the aid of cutting-edge technologies like data mining, machine learning and natural language processing, it gives us proactive tools to identify and stop the spread of extremist content and recruiters on online platforms. This comprehensive system improves our capacity to counter terrorist ideologies and contributes to a safer online environment with a user-friendly interface for real-time URL assessment. Among the algorithms, gradient boosting stands out as a standout performer, enhancing our defense against evolving online threats. Thank you for watching this video.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.